So in this section, we study more about the applications of the normal distribution. Again, the normal distribution is a distribution that has the normal curve, the bell curve. So there are two objectives for this section. Find and interpret the area under the normal curve, and also find the value of a normal random variables. So now we are going to standardize the normal curve. So the reason that we are going to standardize the normal curve because it's easier to find the area using the standard normal distribution table. If you don't have the TI-84 calculator, we can also use the normal distribution table, the z-score table, and in order to find that, we have to find the standard normal curve. So for the standard normal curve, the mean would be 0 and the standard deviation should be 1. So for the standard normal curve, your mean should be 0 and your standard deviation is 1. So we use the z-score formula to convert to the random variable x to the z-score. So again, the z-score is found by x minus the mean divided by the standard deviation. And you see that the mean now is 0 and the standard deviation is 1. 0 plus 1 is 1. 0 minus 1 is minus 1. Okay, alright, so let's move on to the example. The IQ scores can be modeled by a normal distribution, so that is the key word. This is the mean, this is the standard deviation. They ask you how many standard deviation above the mean is an individual whose the IQ score is 120. Again, the z-score is telling you how many standard deviation above or below the mean from that value. So we found the z-score equal x minus mean divided by standard deviation. This is the score minus the mean divided by the standard deviation, and you got 1.33. So this is 1.33 above the mean. Now, what if we are asked what proportion of the individual has the IQ score of 120 or higher? Again, 120 has the 1.33 for the z-score. Now you want that to be higher. You want everything to be higher. Or what is the proportion? Again, the proportion is the area under the curve. So we are looking for all the area under the curve to the right side. And we would need to find the area under this standard normal curve. Again, the standard normal curve, we stack from the mean of 0 and we go to the right. This is the z-score axis because we convert everything back to the z-score. Now, to find the area under the standard normal curve, we can use the calculator or we can use the function, the distribution table, the z-score table. But let's try to find that using the TI-84 first. Okay, so to find the area using the TI-84, we use the function called normal CDF. CDF stands for the cumulative distribution function. So we would go to second vars to get to the distribution, and then we pick the option normal CDF. Now this function takes the lower bound, the upper bound, lower limit, upper limit. Lower limit we stack from 1.33, and then the upper limit. Now we want all the way to the right, Remember, it's keep going forever to the right side. So you want the right side to be positive infinity. However, we don't have that simple. that notation on your TI-84, and therefore you just have to pick a value that is extremely large to the right. And I could use something called a 10 to the 99, right? Just to make a value super large to the right side. 10 to the 99, make it super large. Or you can just use like 99999. That's good enough, okay? You want all the way to the right. The mean is 0. The standard deviation is 1. That is the standard normal distribution. And then paste that function and then hit the enter, and you should get the value of 0.091. So that is the area under the curve using the TI-84. We can also use a z-score table on the website to find that value. So you can type the z-score table, and they have a lot of good z-score table on online here. Okay, so the z-score table, you can find that inside your textbook or just Google it. In this case, we are looking for the value of 1.33 for z-score. Okay, so now if you go to here, this is the negative z-score, so ignore that. Let's go to the positive one. So 1.33, so this is 1.3. So you would need another 0.03, which is right here, the column 0.03 together with 1.3 will give me 1.33, or the value is 0.9082. Now this is very important. This value here, 0.9082, that is the area to the left side of the z-score. So the z-score table only gives you the area to the left side of that z-score. But we are not looking for the left side. We are looking for the right hand side. So in order to get the right hand side, remember the area of everything is 1. So if you get the area to the left side of that value, in this case we got 0.9082. So 0.0982, which is the left side. So we take 1, we subtract this value, then we would get the same thing, which is what we got earlier, 0.091. So let's try the subtraction. 1 minus 0.0982. Then you would get the same thing here, 0.9018. Right, same thing. So that's how we use the z-score table to find the value if you don't have the TI-84. But I recommend that we use a TI-84 because that will give you the most accurate answer. And then this is more example of finding the area under the standard normal curve. Now they ask you to find the area under the standard normal curve to the left of the z-score. Okay, so now they give you the z-score. They want you to find the area to the left of that z-score, minus 1.38. So that's pretty simple. Again, we use the TI-84 second distribution, and then go to normal CDF. The lower Let's clear that here. Okay, the lower, you want all the way to the left side, negative infinity. So I just put a very large negative value, minus 9999. And then we go all the way up to minus 1.38. Or you can put like minus 10 to the 99. Doesn't matter. The mean is 0, standard deviation is 1. So we hit that, hit enter. You should get the value here. And then the same thing here. We go all the way to the left up to 0.87, and then you should get this value. So that's just the way that we use the TI-84 to calculate the answer of the standard normal distribution. And then to the right side is the same thing. So let's just pick one example and do that. Let's do this one here. Question 3. Here, very straightforward again. Second distribution, normal CDF. Lower, you want from negative 0.21, and then all the way to the right, so 99999, or 10 to the 99, as long as you pick a very large value, and then hit enter, 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 and that is the value that we get here. Now on Excel, we can also use the function normal distribution to find the area under the curve. So if you open Excel, alright, open Excel. Let's click on a cell, click the equal sign, and then go to insert formula. Go to formula, insert function, and then choose statistical. Okay, so go to insert function of the formula, pick statistical, and then scroll down and choose something called normal distribution. Norm dot dist, normal distribution, and click OK. Now the x value in this case, so if you are using the Excel, it's similar to the value that you are using from the TI-80, the table, the distribution table. So the x value is the value that will give you the area all the way from the left up to that value. So in this case, we want to find the value of the area from minus 0.21 and all the way to the right. So this is the point that we are looking for. So if you enter minus 0.21, however, Excel, if you enter this point, it will give you all the area from the left up until this value. So if you type 0.21, you get the area from the left side of that. But that is not what we want. We want the area to the right. But that, if you are using Excel, you have to do it this way. Type this number in, then you will get the area to the left of that, and then take 1, subtract that value, will give you the area to the right. The mean, again, the mean in this case 0, standard deviation is 1. Cumulative, yes, you want all the cumulative area all the way from the left up to that value. So you want to put the logical statement, the value true. That means you want all the value from the left side until that point. Now you see that you get this value. This value is not what we got here, because this value is the area from the left side only. So to find the area to the right side, we take 1 minus whatever we got here, and you get the value right here. So again, Excel will not give you the area from the right side. It only gives you the area from the left side of whatever the point that you put in. So in this next example here, we are looking for the area under the standard normal curve between the following two z-score. So now it's not all the way from the left or all the way from the right, but the middle value. Now that's also easy to find if you are using the normal CDF function of the TI-84. So let's try that here. Between these two values, you click second first, and then you go to normal CDF. The lower is minus 1.21, the upper 0.98, mean is 0, standard deviation is 1, so that's all good, and you will get that value. So if we are using the TI-84, then that is easy, because they give you the function with the input of the left and the right limit. And then the same thing here, just input the two values. Now if you are using the Excels, then it is difficult. It takes more time. So let's try that using Excel or using the table. How about let's try to use the table. Okay, so let's try this example using the table. So we have minus 1.21, minus 1.21. So if you go to the table, minus 1.21, minus 1.2 is right here. We need another 0.01, which is this value. Okay, because this is the column 0.01. So minus 1.21 is this value. So this is 0.1131. 0.1131. 0.1131. Now that is the area of the left side. So from the left side of minus 1.21, which means all the value of the left side. Again, this is not what we are looking for. However, we'll need that value. Now, let me show you the next one. 0.98. 0.9 is right here. We need another 0.08, which is right here. 0.8365. This is 0.08. So 0.8365. Okay. 0.8365. Now again, this is what? This is the area to the left side of 0.98. So everything to the left side of 0.98. Okay? Everything to the left side. Now, if you look back, we only want the area with the red portion only. So in order to get this area only, you take the whole yellow portion, which is this number. We subtract the green one, which is this value, in order to get the red portion only. And then if you do that subtraction, let's try that. Minus 0.1131 and that should be 0.7233. Okay, so using the table, it takes you more steps to get the answer if you don't have the TI-84, because it will only give you the area to the left side, so you will have to manually do the subtraction between those two. That's why I still have to find the area of two of them, so that I can do the subtraction and still get the same answer. And this is just the step that we did in the last few examples to find the area under any normal curve. Again, standard normal curve is when the mean is 0 and the standard deviation is 1. Okay, so in this example, again, we are trying to find the area under any normal curve. The IQ scores can be modeled by a normal distribution with the mean of 100 and a standard deviation of 15. So we know that this is a normal distribution where you can know that you can draw the normal curve. Now they ask you to find what is the proportion. The proportion is the area under the curve of the IQ score of 120 or higher. So we draw the normal curve. The peak is at the center, and the center is also the mean value, which is 100. And then the standard deviation is 15. So if you add 15 above 100, you are moving one standard deviation above the mean. If you subtract 15, you get 85. That is one standard deviation below the mean. But we are looking for 120, so that is a little bit higher than 115. We are looking for 120 or higher, so all the area, the red one, all the way to the right. Now we can do that by using the TI-84 or by using the table. Let's try to use the table. If you are using the table, you must first convert it back to the standard normal curve. Now, what is the corresponding value of 120 on the z-axis? So you have to use the z-score formula, x minus mean divided by standard deviation. The value of x is 120, which is the point that we are solving for. That will give me the z-score of 1.33 is right here. So 1.23 is on the z-scale. 120 is the normal scale. So we go back to the table. 1.33. 1.3 is right here. So you need another 0.03 to make it 1.33. And that is this column, 0.03. And that should give me this value, 0.9082. Remember, this is the area to the left side of that z-score, 0.9082. Okay, so let me write here. That is 0.0982 to the left side of that z-score. However, we are not looking for this value. We are looking for the right area. Remember, everything is 1. We know this value, we take 1, we subtract 0.0982. You then get 0.0918. So that's how we find the area using the table. Now, if you have the TI-84, then that should be straightforward. We use second distribution, and then this is the normal curve, so we use the normal CDF function. And we enter the lower bound. In this case, it's 1.33. And then the upper bound, we want all the way to the right, go to infinity. So I place a huge value, 9999999. And then my mean, I'm using the z scale, the standard normal curve. The mean is 0, standard deviation is 1. So this is already the correct values. So we input everything. hit the enter, and you should get that answer. So that's how we find that using the TI-84 or the table. And then the next question, what is the probability that a randomly selected individual has an IQ score between 80 and 125? Now this is the middle interval, and again, we don't have to convert it to the z-score if you are using the TI-84. We can use the same formula, normal CDF. The lower, you want that to be between 80 and 125, so I put 80. The upper, it's 125. We want to stop here. Now in this case, we use the regular number. This is not the z on the z scale. Therefore, the mean, you have to adjust it to the regular mean, not the standard normal curve. We knew that the mean was given as 100. Like 100. So, and the standard deviation is 15. So this is a normal scale. And then we have everything, and then hit the enter, and you should get the value 0.8610. And that is how you solve this type problem. And the next one is finding the percentile. This is another type of question. So they look for what is the percentile. Percentile is the same thing as asking for what is the percent of that number, ranking of that individual whose the IQ score is 132. So we know that the mean is 100. One standard deviation is 115. We add another 15 points, and then two standard deviation is 130. We are looking for 132. So what percent is at this point? So if you recall that we know that all the way to the left, this is 0%. And then all the way to the right, this is 100%. Now, 130 is around here. So what is the percent at this point? Remember, the percent is the same thing as the area or the proportion or the probability to the left side of that point. What we do now is all we do is we look for the area, all of the area to the left side of that 132, all the area to the left side. And we came back to the same problem that we did before. So finding the normal CDF again, we go all the way from the left. I put a negative infinity or negative 10 to the 99, which is a very negative value. And then the upper bound is 132. We are using the regular numbers. So make sure your mean is the regular mean, 100. Standard deviation is 15. You put that in the TI-84, you should get this value. And this one is what? This one you can convert it back to 99.36%. So this value here has the percentile of 99.4%, around that. Now this is another example of finding the z-score of a normal random variable. So this is the opposite problem of what we saw earlier. Find the z-score that corresponds to the 85 percentile. So remember, they asked you for the z-score. So we are talking about the z-scale. The z-scale of the normal distribution has the center of 0, and then 1, 2, 3, and then -1, -2, -3, and so on. Remember, all the way to the left side is 0%. All the way to the right is 100%. We are looking for the 85 percentile. So 85 should be almost close to 100, right? 85% mean, but 85 percentile means from here and all the way to the left is 0.85. So we are given the area. In this problem, we are given the area all the way from here and then to the left side. what is the value of this z-score that gives you the area of 0.85. Remember, before we was given the z-score, we had to find the area. But now we are given the area, we find a z-score. So that is the opposite process. So we can do this again by two ways, using the table. So if you go back to the table, the numbers that you see inside the table, those numbers here represent the area. And the number on this column or this horizontal axis is the z-score. Now we are given the area, we are looking for that z-score the opposite way. So 0.85, we look for the number of 0.85 inside the table. So that could be this one here, right, 0.85. So choose the smallest value close to 0.85. So this is we have a few 0.85, but this is the smallest one. So this value corresponds to 1.0 and then 0.4. So together that should be 1.04 for the z-score. So 1.04. So this value right here is 1.04. So by the table you can find the z-score, or if you use the TI-84, you can find that as well. You can do that. Let's do that here. So we use the second distribution to get to the distribution list, and because we are using the inverse process, we use an inverse function, inverse of normal. Now the area is the area to the left side of that z-score that you are looking for. This value, the left side of that, has the area of 0.85. We are talking about the z-score. The mean is 0, the standard deviation is 1. This is the standard normal curve. Enter, 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 and then hit that, you get 0.04, 1.04. So using the TI-84 is a quicker way to get to the more accurate answer and faster. Comparing by looking on the table and then trying to find 0.85, sometimes it's difficult. But if you can do that here on the TI-84, it's a much quicker way to get the answer. So in this question, we are given that it is known that the length of a certain steel rod is normally distributed. So that is the big keyword, normally distributed. So we know we can draw the normal curve. We have the mean of 100 centimeter, standard deviation. Now, suppose the manufacturer wants to accept the 90% of all the rods manufactured. Determine the length of the rods that make up the middle of 90% of all of them. So you want to see what is the value of the rods that has 90% accepted in the middle. So, or in another ways of writing that is, we know that we have 90% in the middle. What should be these two values? We know the mean is 100 at the center. So what should be the x1 and x2? Now the whole thing is 100. If this is 90, then this here should be 5%. And this here should be 5%. Together, they are 100. So 5% means 0.05. So that's pretty simple. And now, how do I find that? How do I find x1? So x1 is easy. You know that this one here is the area with 0.05. So you are given the area. You want to find x. So that is the inverse norm function again. So we go back to the TI-84. We do the inverse norm process. Second, distribution, inverse norm, the area 0.05. Now in this case we are not using the z-score, so make sure you adjust the mean. The mean is 100. The standard deviation 0.45, and that will return a number, the length of the rod, 99.26 centimeter for Act 1. Same thing for Act 2. Now we know that this is 5%, this is 90%, so together 95% below Act 2. So we use a different color here. Act 2 is right here, so below that we have 95. 90 together with the last 5%, together is 95% for the red, for the yellow area. So given the area of 95%, what should I find? How do I find the value? So same thing, second distribution, inverse norm, area is 0.95, and then the same mean, standard deviation, and that should give me 100.74 centimeter. So the steel rod has the length between these 2 centimeters, X1 and X2, below 100, and then a little bit after 100. So that is the 90% of all the rods manufactured that they accept. So this is another topic, the follow-up concept, Z alpha definition. So we are using the notation Z alpha, Z sub alpha is the z-score such that the area under the standard normal curve to the right side of that z-score is alpha. So whatever alpha I write here, that becomes the area to the right side of that z-score. So for example, when I write z sub 0.23, this is the alpha, or that is the area to the right. This is the area right here to the right, and it has a value of 0.23. So if I ask you to find what is z of 0.23, what is that z-score that gives you the area to the right of it to be 0.23? We know that in order to use the norm, inverse norm, we need to apply the area to the left, not the right. But remember, everything is 1. So to find the left area, you take 1, subtract the right, and then input that as the left area to the inverse norm function, and that will give you the z-score of that point. And then the same thing to this problem. We use 1, subtract that, and then we use inverse norm to find the value of that z-score.